Endport virtualization, or node port virtualization, is very important to today's fiber channel and FCOE networks. It helps us solve many issues, which can be compatibility between two different vendors' types of switches. It could be the fact that we actually have a limited number of full-fledged fiber channel switches that we can use on a traditional network. And that's because of the fact that for every storage network or virtual storage area network that we run on our SAN topology, it takes up resources on the switch. So we actually have a limited amount of resources and a limited amount of fiber channel IDs that we can use. And we need one fiber channel ID per switch. Now, network port virtualization allows us to not have to use an ID. And it's used a lot of times with virtualized servers or even in UCS. Because what it allows us to do is it allows the switch that the virtualized server or the UCS connects to actually proxy logins to the actual fiber channel network. And because we're proxying the logins, we're actually not running full storage services, and we don't need a fiber channel domain ID. It also allows us to have more than one worldwide name associated with a single port, where previously it was one name per individual port. So this solves a lot of problems with us. There's no need for interoperability because we're just proxying the requests northbound. And there's no need for additional fiber channel device administration because we're not actually running any storage services on that device. We're just proxying it up to the next device. So we can very easily add technologies like UCS to your existing storage area network, and you can administer it the same way that you always have because we're actually not doing any of the work on the UCS device. We're sending that up to your existing storage area network. Now normally, these connections between the NP switch, which is the host, and the MPV switch, which I think of as the server switch or the parent switch, are more like access ports or fabric ports, as you can see in the diagram, which normally have a single vSAN associated with those. But with a feature that Cisco has called F-port trunking, we're actually able to take that F-port and run multiple virtual storage networks across that single port. So with some vendors, where we can only support one vSAN or one storage area network per port, with Cisco, we can actually support multiple vSANs per uplink and still make it easy by using NPV. Above and beyond that, we can also enable port channeling on that link and create redundancy. When you want to use this feature, you have to enable it in NXOS by using the feature command. And in this case, it is Cisco proprietary. But I believe that if you are using MDS and you are using NPV in your environment, it'll be a very useful feature for you to provide reduced configuration and extra redundancy inside your environment. Please join me for the next lesson, 17.2, Examining Zoning Models.